Welcome to Snowflake-cost optimization session. In this session, we are going to discuss about virtual warehouses right sizing. Virtual warehouses computation resources and cost scale exponentially. Always start with X small. Increase the warehouse size until the query duration stops halving. When this happens, the warehouse is no longer fully utilized. For the base cost to performance ratio, choose a warehouse size one smaller. A warehouse can run more than one query at a time. So wherever possible, keep warehouse fully loaded and even with light queuing for maximum efficiency. Oversized warehouses can sometimes make up most of the Snowflake uses. So in this below table, you can see if I have X small virtual warehouse, it provides me one node and eight thread, but it charges me one credit per hour. If we go from X small to small, it gives me a two node 16 threads and it charges me two credit per hour. If I go from small to medium, it now increase two from two node 16 thread to four node 32 threads and it charge me 4 credit per hour. So in this way, virtual warehouse computation resources and cost scale exponentially. Let's see this with an example. So consider a data ingestion job that loads 8 files every hour on a small warehouse. A small warehouse has two nodes and a total of 16 threads available for processing. So for these 8 files that need to be ingested to the Snowflake, right? Uh, uh, right, it will only utilizing 8 threads, and these next 8 threads are in idle state, and that's why this thread particular node is not in use. And that's where like large warehouse sizes is not necessarily a faster. For smaller basic queries that are already executing quickly, you may not see any significant improvement after resizing. So if I go from small to extra small for the same thing, right? So it will utilize entire node and all the thread optimally, optimally as well. And that's where you can see a small warehouse could be a powerhouse here. Now let's consider using cost factor here. So if you see for extra small warehouse, it provides you one node, eight threads, and credit is one credit per hour. So that means if it's run entire 1 hour, it will credit you a one credit. So let's assume one credit is equal to a dollar to cost. So based on your Snowflake edition, this cost per credit is different. I just for simple calculation, I just use $2. So for extra small warehouse, it charge if it's running for 1 hour, it will charge you a $2. If we go from extra small to small, it will charge you a $4. And same case with medium, if it's run for 1 hour, it will charge you $8. So and that's where like the way we increase our resources, it will increase our cost exponentially. So in the previous example, uh, when we first use small warehouse, it costs around $4 per hour, but when we downgrade to extra small for same amount of work, it now costs $2 per hour. So that means it's directly a 50% saving. So let's check this in a demo. So for that, I'm using SnowSQL as a to load the data to Snowflake stage environment. I do have uh, two warehouses created within my Snowflake. Like one is a compute warehouse, which is extra small, and one is a load warehouse that is a small one. And I have taken these 8 files that I am going to load it into the Snowflake stage area. So let's go and use that. So for that, I'm going to use my database as demo database. Then I'll go to my schema as customer schema. Then I'll go with a small warehouse. Use warehouse load where WH warehouse is my small warehouse. Now I am using a SnowSQL put command to load data to the customer stage. Let's wait for some time. Now you can see within a 17 seconds, this data get loaded to this Snowflake stage. I use small size warehouse. Now let's remove the data from stage area. So we'll again test with a extra small warehouse. So I'm just running the again query. I'm just changing my warehouse from load warehouse to the compute warehouse, that is extra small one. And now I'm again uh, loading the data to Snowflake stage using extra small warehouse. Let's wait for a couple of seconds. You can see now using extra small, it took around 15 seconds as well. So you might wonder like, if I have more files, like instead of 8, if I am having a more files. So let's test that as well. I'll just copy the similar data here. So now I am having a 16 files. So first I'll just load the data using uh, a extra small warehouse, and let's see how that performs from here. So let me again put those 16 files in a Snowflake stage. Let's wait for a couple of seconds. So you can see 27 seconds it took around to load those 16 files. Let's use the small warehouse and do the same activity again. So I'm just changing my warehouse to the small warehouse. Use warehouse, load warehouse. Then now I'm loading again those 16 data back to the stage area. So just wait for some time. So you can see for using small warehouse as well, it took around 27 seconds, and for extra small it's again took around 27. So exactly the similar amount of uh, time it took to load the data, even we have a very large number of files. Let's move to the presentation step, and that's where, right, we say initially that bigger that nothing means it's faster. Let's move to the presentation part. In the next part, we'll see like virtual warehouse consolidation, what that mean. So let's consider like when there are too many warehouses, many of them will not be fully saturated with queries and they will sit idle, resulting in unnecessary credit consumption. The best way to ensure virtual warehouses are being utilized efficiently is to use a very few as possible. Wherever needed, create a separate warehouse based on performance requirement versus domain of workload. Let's understand this with some graphical representation. So let's you have a warehouse setup like this. You have a marketing warehouse. You have multiple teams in your company like marketing team, finance team, analyst team, right? For querying data via Snow site, right? You have per department wise, you created a marketing extra small warehouse, finance extra small warehouse, analyst extra small warehouse. For loading data, for marketing team using marketing load warehouse, analyst team like doing any kind of ETL transformation within a Snowflake, it uses analyst ETL warehouse. And for reporting need or business intelligence need, marketing team using marketing BI warehouse, and finance team using finance BI medium warehouse team. When I say consolidation of the warehouse, right, instead of creating a warehouse department wise, just create a warehouse in the functionality wise, like you create a extra small warehouse which is for running queries from console or Snow site. Loading data to Snowflake, you can use load warehouse. Transformation purpose, you can use transform warehouse. And business intelligence or reporting need, you can use a business reporting uh, uh, warehouse. So in this way, right, you can consolidate, like for example, all these three marketing, finance, analysts, you can consolidate to the console warehouse, marketing load warehouse, you can consolidate to the load warehouse, analyst ETL, you can consolidate to the transform warehouse. And for BI related use cases, right, you can utilize the BI reporting medium uh, warehouse. So in this way, right, even first time if marketing team is executing the queries and finance team also executing the query, right, the same warehouse get utilized and it get utilized efficiently. And that's where I mentioned like warehouse consolidation. Thanks for watching the video. For more tips, do subscribe to the channel. Thank you.